Hello, this is Brock Lemires. We're continuing our study of embedded systems design by looking at program flow instructions. In this video, we're going to look at implementing an assembly language program from a flowchart. So this is the flowchart that we have been given, and we are going to create a new CCS project to implement this. And so we take a look, let's just say that this was done by either ourselves or somebody else, and now we're in charge of actually writing the code to do this. So let's just look at this and think through a few things before we actually start coding. Okay, so I'm going to go through block by block. So var1 plus var2. So it appears that there's going to be two variables that are added together, and then it looks like there's a decision that will need to be made based upon a carry or not. And then depending on whether there's a carry or not, you'll have yes or no. You will go down and do an assignment to a third variable called fit. And it looks like if there's a carry, it did not fit. So fit must mean you're looking at whether or not it fits within the number of bits that you have, let's say 16 bits. And if there was no carry, then, okay, so then right here you'd say it does fit, okay? So you have two instructions right here, and only one or the other will actually be implemented. So I can kind of see that there's like a task here. That seems pretty straightforward. I guess first and foremost, we need to set up three variables and we can choose to do that in registers or we can choose to do it in memory. I think for this program, let's put these three variables in memory, and that will allow somebody else, I assume these are coming from something else, like some other routine. And if we put it in data memory, then we can allow that other routine to actually give us the variables and then they can see the result. I can clearly see that this is an if-else statement because it's going to come down. We're going to look at one thing, which is the carry flag, and either execute this or this. And when we finally get done, I notice this arrow coming back here. This is an infinite loop. Okay, so basically I know that we're going to be in like a while one situation or a main jump main. So we're going to sit here and do that. Okay, so I think we got our brains wrapped around this. Let's let's fire up CCS, and we'll leave that flowchart right there, and we can do a project to implement this. All right, so let's do file new CCS project, and gotta get our board plugged in here, and we're gonna call this ASM, and then we'll call it flow, and then we'll go design from flow chart. Okay. All right, and then we're going to do an empty only. Go ahead and finish that up. And here is our main file. Okay, so first and foremost, let's set up the variables. So I'm going to come down here and I'll put a little comment block that says data allocation. Let's come down here. We'll do a .data, which means go to data mem at 2000 hex dot retain, which means leave this section alone. And then let's set up three variables. So one of them is going to be called var1, and let's just make it 16 bits. var2 dot space is a directive to reserve bytes, and I give it 2 bytes. And then it looks like fit is our third. So I have dot space and 2. Okay, so I'm not initializing those, as I'm just setting them up. Okay, so then we go up into my main loop. And first and foremost, let's just do a main. And then we'll come down here and do a jump main. So that right there just coded up the loop. Okay, and now let's go through and let's just walk through how we do this. Okay, so the first one, this first little process block, I can do this a couple different ways. But let's just do it like this. Let's just go move.w var1 into r4. And so we use symbolic addressing for the source. We use register addressing for the second. We could have just done add var1 to var2, but that would have blown away var2. Okay, so what I want to do is I want the sum to go in a register so that I don't edit or alter these variables in program memory. Okay, so now we're ready to do add, and we'll go var2 to to r4, and now the sum is sitting in r4 equals the sum. And we don't really care what the sum is. All we really care about is whether or not there's a carry or not. So I'm going to go down here and I'm going to set my label for carry and then no carry. And then right here we'll have, and then we'll do, okay, so this is the code that we're going to have to do the fit is equal to 0 or fit is equal to 1. So now that I have those labels, I can actually come up with my jumps. So I'm going to do jump if carry to carry. And if it's not carry, if there is no carry, I need to hop over that. So I need to go, I can do jump if no carry to no carry. Now this is interesting because I do jump if no carry. I could have used jump here actually, because if there's a carry, you go there. The only other option is that there is no carry. So I could have done a jump here, but we have this instruction anyway, so let's just use it because it's a little bit more readable. Okay, so this is going to do this right here, and now I've made my decision, and now I'm finally down to these little blocks right here. So let's go ahead and do the instructions for if there's a carry. So all I'm going to do here is do move.w, and it looks like we're going to put 0 into fit. So I go 0 into fit. So I use immediate mode addressing for the source, and then I used symbolic for the destination. But then the trick here is I gotta hop over the code that's going to go here for no carry. So otherwise, I'll just march right down to it. So I'm going to need a label called done, and what I'll do is I'll do jump done. And I'm writing this so that it's very sequential and follows this chart. You could probably see that I could have jumped back up here to main after I was done with that, but let's just do it this way for no reason. All right, a lot of different ways to make a program. And let's come over here and we'll do this. Now we're at no carry, so I'm going to go move W #1 into fit. And now at this moment, I can do jump done, or I cannot do jump done. Because if you notice, I don't need to jump done. I could jump back to main at this point also. Okay. All right, there it is. But I kind of like this because it looks more readable. But a few extra instructions to make it readable. But anyway, there you go. All right, so let's fire this up. And what I'm going to do to test this is I'm actually going to go directly into memory, and I want to put numbers into var1 and var2. And this is a 16-bit. These are 16-bit words, so they're big. They can hold up to 65,000 each. 535 or whatever it is. So these are big numbers. So if we want to generate a carry, we're going to have to really think about it. Okay, so what I care about is I want to see the carry flag, and I'd like to see R4. And should we do it in decimal? Let's do it in hex. We haven't been a while since we've done hex. Let's go down to data memory, and we see our 3 variables right here, and then this is going to be fit right here. Okay. All right, life is good. So we'll go down here. Let's go ahead, set a breakpoint, run to it, and let's put a number in here. Okay, so first of all, let's do, let's go right here, and I'm going to put FFFF into var1. Okay, and if I go var1 plus FFFF plus 0, then nothing should be in there. Okay, so let's go ahead and step. So I'm going to go step. This is move var1 into r4, so I saw my value come in. Right, let me move that down. I saw that come in, and then I'm going to go step again, and I added to it, so nothing was added to it. And then, actually, yeah, let's just do this. And then we went ahead and said jump if carry. Notice there is no carry, so it should not do that jump. Then it jumps to no carry. We move 1 into fit, which I'd already had 1 in there, and then we go back. Okay, well, looks good. Let's try this one now. Let's make sure that we're even doing something. So I'm going to do delete. Let's do FFFE in there, and then we'll do 001 there. And now let's see what happens. So now I'm going to go ahead and go step. I move FFV into R4. I add 1 to it, so I saw that a 1 happened. There was no carry generated, so then I don't jump to the carry. I jump to the no carry, and that worked. Okay, now let's test our final, which is let's add like 2, and that is going to generate a carry. And then we should have fit should go back to 0. Okay, all right, so I'm going to step, brings in FFFE, and it's going to add 2 to it. That rolls over R4 and sets the carry. And then I'm going to jump if carry. I jump to carry. So I go ahead and fit now finally went back to 0. And then I jumped over my no carry code and I did it. All right, that is it. So Pretty straightforward once you get the flowchart designed. And remember, that's why we do the flowchart. It helps you think through your thoughts. And once you have a flowchart, coding the assembly is relatively straightforward because each of these blocks represents little chunks of code that is pretty straightforward to implement. All right, there it is. Remember, support my channel by subscribing so that I can continue to bring you all these cool videos. See ya.